All right, good morning. Welcome back to Calculus 2. We are going to be trying to figure out the area between y is equal to x minus the square root of x minus 1 and x minus y equals 1. Okay, this is clearly a line, but I wrote it in the most inconvenient way possible. So let's go ahead and add y to both sides, subtract 1 from both sides, and we'll say this is x minus 1 is equal to y. So figuring out, okay, we need the area between the square root of x minus 1 and x minus 1. Next, we have to do is figure out where the heck do these two things intersect. So we're going to set them equal to each other. So we have the square root of x minus 1 equals x minus 1. Well, I got a square root. The way to get rid of the square root is to square it. Don't just square the terms. Go ahead and square it out. So we end up with x minus 1 is equal to squaring this. I'm going to do this in my head. X squared minus 2x plus 1. So we're setting these equal to each other. Okay. So let's go ahead and add 1 to both sides. Let's go ahead and subtract an x from both sides. So here we have x squared minus 3x plus 2 is equal to 0. I think I can factor this. So that's going to be x minus 2, x minus 1 equals 0. So we can claim that x is equal to 1 or x is equal to 2. All right? So when I'm setting up my integration factors, we're going to say this is going to go from 1 to 2. And then did I know which one is going to be on top of the other one? Well, let's pick any point in between 1 and 2. You don't have to pick the average, but I did. So let's go ahead and do my x little star here to be 3/2, 1.5. Okay. And it will plug them in and see which one is bigger. Okay. So we have the square root of 3/2 minus 1. Okay versus, and this is going to be y is equal to x minus 1. So we have 3/2 minus 1. Which one is bigger? Okay. So 3/2 minus 1 is the square root of 1 over 2. And how does this compare to actual 1/2? From trigonometry, right? The sine of pi over 4 is going to give me 1 over square root of 2. And remember from trigonometry that 0.707 versus zero point 0.5, the square root is bigger. So we're going to say the square root of x minus 1 minus parentheses x minus 1 dx. Now, as I'm looking at this, I'm noticing there's a lot of x minus 1s here, and I really don't want to go through and figure some of this stuff out because it's inside of a square root. How delightful. So what I'm going to do is I'm going to say, you know what? Since we have a lot of x minus 1s, let's set u equal to x minus 1. Not the square root, just x minus 1. du is, of course, dx. And we're going to change our limits of integration. So we're going to say when x is equal to 1, u is equal to 1 minus 1 equals 0. When x is equal to 2, u is equal to 2 minus 1 equals 1. So this is working out really well. So we can feel really clever here. So this goes from 0 to 1. These are now u limits. And I've got u raised to the 1/2 minus u all times du. And we just have to integrate this piece. This isn't going to be bad at all. So we have u raised to the 3/2 times 2/3 minus 1/2 u squared. And of course, we're going from 0 to 1 in my new u limits of integration here. So plugging in 1, that's not going to be too bad. We have 2/3 times 1 raised to the 3/2 power, which is 1, minus 1/2 times 1 squared, which is 1, minus, we plug 0 in here, we get 0. Okay, that's delightful. Okay, I mean that this time. So we end up with 2/3 minus 1/2. Go ahead and get in common denominators. So we have 4 over 6 minus 3 over 6, giving us 1 over 6. And that is my area between these two curves. They don't all have to be the hardest problem. Uh, this one's kind of nice. The hardest thing we had to do is note that u could be x minus 1 to make the integrations a little bit easier. Okay. Thank you very much for watching the video. I'll see you in the next one and take care until then.